Techron's 3110A is a powerful yet simple-to-use audio bandwidth standards waveform generator. It contains everything you need to generate any waveform and comes preloaded with an extensive library of tests, including hundreds of automotive and aviation standards. In this video, we will review the process of performing a system calibration using an oscilloscope. For precision testing applications, this process may also be used to compensate for any linear voltage drop between the system output and the voltage across the load, either at a fixed frequency or due to DC resistance of the cables. This is just a basic overview of the steps involved. Please see the 3110A help manual for more complete details and instructions. Ensure that your oscilloscope input is configured for DC coupling and is configured for high impedance input. For this process, you will be monitoring the voltage output of your system using a differential probe with at least 20 times attenuation. We will be measuring two values. The maximum output amplitude in volts peak will be used to calibrate the total system gain, and the mean amplitude, which will be used to calibrate any unintended DC offset. After opening the 3110A software, click the Settings button in the upper right, then click on the System Calibration tab. In this example, our 3110A has the default settings, with a DC offset correction of 0 volts and a system gain of 20. However, your system does not need to be reset to default values since this procedure is the same regardless of starting values. The first step in the calibration process is to set the DC offset. In this example, we are measuring frequency, but this is not necessary. Set your oscilloscope to measure the maximum amplitude and the mean or average amplitude. If your oscilloscope does not have a method for measuring mean amplitude directly, you can substitute this for calculating the difference between maximum and minimum amplitudes by hand. You will likely see some amount of noise in the system. For our setup with no signal, we are seeing a mean amplitude of 390 millivolts or 0.39 volts. In the setting window, I am entering this value, which is positive 0.39 volts, in the measured DC offset field, then clicking the top Apply button. We should now see the mean value get closer to 0. Since there is still some measurable DC offset, we will repeat this step to get closer to a 0-volt mean amplitude measurement. For the second iteration, I am entering the new mean value, 0.04 volts, into the measured DC offset field and then clicking the top Apply button again. Depending on your setup and precision requirements, you may continue adjusting the DC offset until you are satisfied with the calibration. Click the Save button when you are finished with this part of the calibration process. The next step is calibrating the system gain. In the Settings window, pressing the Run Calibration Test button will cause your system to output the test signal according to the requested amplitude and the frequency. If these settings are not at their default values, please change them now to 1 volt peak and 1 kHz. After pressing the Run Calibration Test button, you will see a sine wave output on your oscilloscope. With a system gain of 20, outputting a 1 volts peak signal, our measured output should be 20 volts. We are reading a maximum amplitude of 20.3 volts, so we need to calibrate the system gain. Enter the maximum amplitude in volts peak, which in our case is 20.3 volts, into the measured output field and click the bottom Apply button. Then press the Run Calibration Test button again. As you can see, our amplitude is much closer to the desired amplitude. We can stop the calibration test at this point, or if your offset is still not meeting your required tolerance, you may continue this process. If during the calibration process the system gain becomes less precise, stop and check that your measurement units are in volts peak and that your oscilloscope attenuation settings match your actual hardware ratios. Any input that causes the system to move further from the target value is a sign that some measurement or input was incorrect. As a final check, we will confirm that the mean voltage is still at 0, which it is. So we are done with the calibration process for the 3110A. If your system measures a different mean value, then you can repeat the DC offset calibration step to correct the issue. This concludes the tutorial for system calibration. As you can see, the 3110A is a powerful waveform generator that is simple to use and easy to get started.